3. We just finished part 2. So here, we're still working with our trig identities, but we want to do what is called verifying trig IDs. Okay, so if you are given an equation has an equal sign. You've got one trig expression on the left and some other one on the right, and you want to prove that those are equal. That's what verifying is. It's proving. Okay, we want to prove that the left side actually does equal the right side. So this is not solving. We are not going to move things across the equal sign, excuse me. Okay, things are going to stay on their side, but we can use identities and algebraic operations to simplify and manipulate it until it matches the other side. Okay, and typically you are going to pick the more complicated side to work with. Now, before we get into some where it's just the equation and you have to do it all, we're going to start with some guided practice here. Okay, so if you think back, you've done something similar to this in geometry. You did proofs. Okay, so this is like a proof where you're going to show your work, like step by step, what's being done. And then next to it, you're going to write what it is you did. What rule did you use? Was it an identity? Was it just some algebraic operation that you did? Okay, so the first couple are going to walk us through. They're going to be a little simpler. They'll get harder as we go. Okay, so in this first one, from the first line, which is what was given, they changed cosecant squared to 1 over sine squared. Okay, can anybody tell me why they were able to make that substitution? It's a reciprocal identity. Okay, so my reason for that step is the reciprocal ID. So I got from this line to this line by using a reciprocal ID. Okay, now here I replace 1 minus cosine squared with sine squared to get from this line to this line. How was I able to do that? Is that an identity or is that an algebraic operation? Look at your list of identities as we're doing this. Look at that tape. Whenever you see a trig function squared, that should clue you in to go and look at your Pythagorean IDs. I'm not saying every time it will be, but that's a good place to start looking if you see trig functions squared. So that table that we made in part 1 with all the different arrangements of the Pythagorean IDs, does one of them have 1 minus cosine squared? And what's it equal to? To sine squared. That's why they're able to make that substitution, because those are equivalent to each other by Pythagorean ID. If you want to actually write out the identity that was used, it's the sine squared plus cosine squared is 1. And it was just rearranged. If I subtracted the cosine over, that's what sine squared equals. Now, you don't have to do that. You can just tell me you use the Pythagorean ID. Okay. All right. Now, how did that all of a sudden become a 1? What happened from here to here? The sine squared in the denominator multiplied by sine squared reduces. So you can just say reduce, or you may say simplify. That was not an identity. That's just an algebraic operation. You can simplify when you have a common factor in the numerator and denominator. And then you're left with just a 1. Does that make sense? All right, let's try the next one. All right, so that first line, I'm just going to put, this is given. So we are given this expression, and we want to prove that it equals cosecant of x down there at the bottom. They've done the work for us. We just have to explain what's being shown. What did they do each step? Okay, so to get from here to here, what happened? What's the difference in these two lines? Is anything different with the first term? No, that's still a plus. So, okay, it's different. How was it changed? Do y'all see what they did? Yes, Alex, you just said it. They got a common denominator. The whole point in this step right here, what is sine of x over? An understood 1. And if we have a fraction trying to be added, you cannot add fractions unless you have a common denominator. So what they did was they said, okay, well, I'll multiply that by sine of x. And if you do that to the denominator and to the numerator, that's fine, because anything over itself, that's like you're just multiplying by 1. Okay, so that's equivalent. So you're allowed to do that. That's an algebraic step. They are getting a common denominator. So get common denominator was step 1. Now that they have a common denominator, what did they do next? Say it a little louder, I didn't hear. It's not really canceling out, but see how it was written as 2 separate fractions and now it's written as 1? They combine the fractions because when you have a common denominator, you can do that. So they combine the fractions. You may think of that as simplifying. Okay, so they simplified this from 2 fractions to 1 once they had the common denominator. Okay, now what was done to get from this line to this line? How did that change? They completely changed their numerator, right? Why were they able to do that? What's the rule that that says that those are equivalent? The same one we used on the last. That's a Pythagorean identity. Sine squared plus cosine squared is 1. Now this one's written as cosine squared plus sine squared, but addition doesn't matter what order, right? Okay, so that is 1 according to the Pythagorean identity. Okay, and then the very last step to get from here to here, 1 over sine is cosecant. What's that rule that tells us that? That is the reciprocal identity. Okay, so we replaced 1 over sine with cosecant. So we simplified that. We've just given the reasons. We've proved, we've verified that those are equal. That top line is equal to that bottom line. So far, so good? All right, so the next one gets a little tougher because they don't do all the work for us. So they give us what we're starting with and what we're supposed to prove that it's equal to, but we have to do the work in between and give the reasons, okay? So I'm gonna start with that top line. That's my given information, so I'm just gonna say given. All right, so let's try and think through what I could do on that first line to try and simplify this some. I see squareds on my trig functions. So I told you if you see squareds, go double check your Pythagorean identities, see if anything looks familiar there. And this one doesn't. This one is the way that it's written now. That is not a Pythagorean ID. All right, tell me what you would do. No, it's not. We're not making an equation. We're just Any other ideas? What did we do day 1, part 1? What was a strategy that I mentioned that I said we would use a lot? I mean, we would use the identities, but to do what? Okay, so write cosecant's reciprocal, which is, what's the reciprocal of cosecant? Okay, and so since this is cosecant squared, it would be 1 over sine squared. Now, the reason I'm going to use this is I'm also going to change tangent squared, but not to its reciprocal, because changing that to 1 over cotangent would not help me at all. What else could I rewrite tangent as? No, I don't want to use the reciprocal there. Yeah, the quotient ID. Tangent is sine over cosine. So since this is squared, it would be sine squared over cosine squared. So this is what I'm talking about, and you still have the -1. This is what I mean when I say day 1. I used the strategy of changing everything to put it in terms of sine and cosine. Y'all remember that? Okay, if we can change things to put them in matching terms, then sometimes things will reduce. Which, do they reduce here? Is there something that's going to be able to reduce? Yeah, you've got sine squared in the denominator and numerator of these two that are being multiplied. So you're able to reduce that. Okay, so let me put my rules. So here I'm reducing. In that first one, I actually did 2 things. I did the reciprocal ID. That's what was in blue. And I used a quotient ID. That's what was in orange. So I'll color code those. So quotient ID was what was changed in orange, and reciprocal what was changed in blue. Okay, and then I reduced it. So that leaves me with 1 over cosine squared -1. That's what? Awesome. Glad you like it. I can make this now. I can change it back to where it's not a fraction anymore. What could I rewrite 1 over cosine squared as? Secant squared. I still have the -1. So that step right there is the reciprocal ID. Now let's check again. I've got my function squared -1. Check those Pythagorean IDs again. See if that shows up on any of them. Secant squared -1. It's a Pythagorean identity. It's equivalent to tangent squared. So those of you, let me see. Oh, I don't have them open here. I was going to pull it back up. But it's at the very end of the part 1 notes where we wrote out in that table all the different ways the Pythagorean identities could be written. Okay, so we did a Pythagorean identity to rewrite that as tangent squared of x. Everybody still okay? All right, let me see what the next one is, see if we have time for it. All right. Let's get this one more done, then we have less to do tomorrow on it. Or Monday, you know. All right. I know that I'm trying to get to where there's no plus or minus sign with what I'm ending with, right? So I'm going to have to get rid of this plus or minus. I'm going to have to combine this to a single term, okay, somehow. Okay, so you actually have a couple of different strategies here. You could create common denominators to combine them, or you could multiply by the conjugate. So actually, I will save this because this is a little more complicated one. There's different ways. So we'll save this one for this. We'll do this at the beginning of class Monday. So if you're watching this on video, this part 3 is going to be split into 2 videos. So go to the second video to see the rest of these notes.